In this video, I'm going to speak with you about something called a correlation matrix. Reading a correlation matrix is one easy way to figure out A, what the correlation is, and B, whether or not it is statistically significant. So let's take a look at this scenario. An organizational psychologist wanted to know if there's a relationship between the big five personality trait of neuroticism and negative self-talk. Do these two things go together? So we have from a statistical software program, maybe something like JASP, this correlation matrix. And from this, we can tell if there is statistical significance. So let's read this matrix. We have the variables on the left. We also have them on the top. And where the two variables come together, we have the correlation. Now you notice some blank lines. That's because anything correlated with itself is a perfect correlation of 1, so we just ignore it. So here we have neuroticism and negative self-talk, and the correlation is 0.284. So what that tells us is that the correlation is basically 0.28 and that it is positive, meaning that as negative self-talk goes up, neuroticism goes up, and lower scores on negative self-talk are related to lower scores in neuroticism. They are positively correlated, right? So the question is it a significant correlation? And to answer that question, we look at the p-value. P-value means probability. What is the probability of finding our Pearson's correlation simply by chance? And so we have a p-value of less than 0.05 is indicated with an asterisk. Well, lo and behold, we have an asterisk here, and our p-value is less than 0.05. Which means we're going to reject the null hypothesis that there's no correlation. We say, yes, there really is a correlation. So to figure out if something is statistically significant, we're evaluating it against our preset alpha level. Again, in social sciences, our preset alpha level is usually 0.05, and 0.01 is less than 0.05, so we say that it is statistically significant. Now, when we're looking at a correlation matrix, one asterisk will mean significant at less than 0.05. If it had two asterisks next to it, it would be significant at less than 0.01. And three asterisks would be less than 0.001. So we can tell the level of significance really quickly by just looking at the number of asterisks next to the correlation. So how do we evaluate a correlation of 0.28? Well, I'm going to give you some guidelines. Now, the guidelines I'm giving you are going to be different depending on the book that you read, the class that you take, but these are the guidelines that we're using for this class. A weak positive correlation is anything from 0.1 to 0.3. A moderate correlation is 0.4 to 0.6, and a strong correlation is 0.7 to 1. And we have the same for negative because they are the same in terms of magnitude, whether it's positive or negative. So we have a 0.28, which is in this weak range, which means that it's a weak correlation. Now we said it's statistically significant, but it's weak. And that can happen. That can mean that, yeah, something is going on here, but it's not a very strong correlation. It's not even a moderate correlation. So statistical significance refers to the role of probability only, like how likely is our correlation? How likely are we to find this if in the population there is no correlation? And so our 0.28 represents a small relationship between the variables. So hypothesis testing gives us two pieces of information. It talks about that probability, the likelihood the result is related to chance, and the strength of the relationship. Let's try out some examples using a correlation matrix that looks just a little bit different, but it's very similar at the same time. I'm going to show you some data on the relationship between diastolic blood pressure readings and overall health scores. Let's take a look. So here's a correlation matrix that has a couple of different variables. It has diastolic blood pressure here on the left, systolic blood pressure readings, cholesterol readings, and waist circumference. And then we also have another variable that's overall health. That's right there at the top. So these are all variables that we can correlate. We can see if they go together. So we were asked to look at diastolic blood pressure and overall health. Find it now in the matrix yourself before I show it to you. All right, we have a correlation of negative 0.258, significance level of 0.17 basically, and an N of 30. So what do we do with this information? Well, first of all, if it had been significant at the 0.05 level, which is what we're typically going to be looking for, it would have had an asterisk next to it, and it does not. But I also know by looking at 0.169, that's not less than 0.05. So I don't have statistical significance here. So our R is a negative 0.26. It's a negative correlation, meaning higher scores on one variable are associated with lower scores on the other variable, which means higher blood pressure systolic readings are related to lower health scores and vice versa. But even though we see a correlation here, it is not statistically significant. That what we're seeing here is probably just random chance. All right, let's try another one. We're going to see if there's a statistically significant relationship between diastolic blood pressure readings, again, and waist circumference. So as the blood pressure readings go up, does that mean that the waist circumference measurements will go up, or will it be in the other direction? Well, let's see. So we are looking for diastolic blood pressure and waist circumference. You find it first. Here it is. We have diastolic is here and waist circumference is here. And the correlation is 0.484. Okay, I see some little stars next to it, so no, we're going to be in the significance level. It has two stars, and in this graph it shows correlation is significant at the 0.01 level for a two-tailed test. All right, and we can confirm that by looking at the p-value, which is 0.007. That's less than 0.01. All right, so what does that mean? It means that we're going to reject the null hypothesis. Remember, the null hypothesis says there's no correlation. We're going to reject that. We're going to say there is a correlation between blood pressure readings and waist circumference. As blood pressure increased, waist circumferences also increases. So these two things vary together, and it's statistically significant. Here's one more. Determine whether there's a statistically significant relationship between overall health score and waist circumference. You hear of this. You hear that waist circumference, if it's larger, can be predictive of some health issues. So let's take a look and see what this correlation matrix says. So we're looking at overall health and waist circumference. You find it first, and it's right there. We have a correlation of negative 0.514. And it's got two dots next to it, which means it's going to be significant at the 0.01 level. And as we look at the p-value, we can see that 0.004 is less than 0.01. So we reject the null hypothesis, which says that there's no correlation. We say there is a correlation between waist circumference and overall health scores. As one score is higher, the other score is lower. So that means higher overall health scores are related to lower waist circumference measurements, and higher waist circumference measurements are related to lower overall health scores. It's a negative relationship. All right, in the next video, we're going to take this a little further.